Welcome back. In this lesson, we're going to look at longitude and latitude. Longitude and latitude, there's two terms, and if you memorize two terms, I promise, if I were to memorize two terms, I would mix them up. I would do one for the other and one for the other. So you're going to see the word long, which makes you have this idea that one is long and one is short. It's a sphere. The globe is a sphere. It's like a ball. It's just as wide as it is long. So one direction is not going to be longer than the other direction. We're going to see that you're going to have on a sphere, as you're turning this into a map, into a flat map, you're going to have wide lines and tall lines. Okay, so wide is latitude, and I would remember this by the word ladder. It comes from the same root. Ladder has the idea that you're stretching out wide so that you can hold on to the sides of the ladder. It's lateral to the side of. And so latitude is going to be your horizontal lines. Longitude then is the other way, or is the vertical lines. So let's look at some of the examples. This entire chapter is on reading a map. And so reading a map requires you to know that this is a model of reality. You don't have a map as big as the world that it's a picture of. It's simply a depiction of something that's bigger. And so in order to find something that's on the land or on the ocean, you are going to have a picture of it, and a grid system is set up. So you have lines of latitude and lines of longitude, and that's what this section is about. So first of all, the art of map making, or the science of map making, is called cartography. So carto from chart, and so it's making a chart. And so you're gridding a piece of paper or a computer model in order to depict the lay of the land. So the lines that you're going to use as reference points are based on the fact that we are not on a flat piece of paper. Land is a sphere. We're on a globe. And so we're going to make some markings in degrees. Okay, so from the equator, which is that center line, it's that horizontal circle halfway in the widest part of the sphere, to the north and to the south, run 90 degrees each. And so these are going to be called lines of latitude. Latitude has the idea of wide. Okay, so as they're going out, so they're going sideways. So latitudes are lines running parallel to the equator. So the equator is a latitude line at 0 degrees latitude. That's the equator. Then these concentric circles go smaller, smaller, smaller until eventually it's a point at the North Pole and at the South Pole. That's 90 degrees from the equator. Okay, so each degree, if you were going to take the distance from the equator to the North Pole and then say that must be 90 degrees, you're going to find that it's about 111 kilometers per degree, okay, each degree of latitude. And the degrees of latitude normally on a map are in tens. So you have 10 degrees north of the equator, 20 degrees north, and then when you get to the North Pole, you're 90 degrees north. So you can take a degree and then divide it by 60. So if you take 360 degrees in the circle, because that's the sphere is based in a circle, so 360 degrees, that's where you get the 111 kilometers. Then in between that 111 kilometers, you have lots of things within 111 kilometers. So you have mountains and you have towns, all those within that ability. So you're going to divide that degree further into 60. And so you would call that into 60 minutes. So you have 60 parts of a degree, and that's 60 minutes of a degree. And then you can take the minutes, divide it by 60, and you can have seconds. That way you can have a plot on your map that actually says, oh, there's where the mountain is, or there's where that pond is. Longitude is the other way. Longitude goes east-west, And just like the equator was the 0 mark for going north-south, we need a 0 mark for going east-west, because any part could be considered 0. So when they made these maps, the country in power at the time happened to be England. And so they decided that the meridian, which are these north-south lines, and these are semicircles, not circles. They go from the north to the south. These medians, or meridians, the 0 meridian would be called the prime meridian. That's the first, and it goes through Greenwich. And so the Naval Observatory is just south of London, England, is in Greenwich. And so 0 is in Greenwich. So if you visit there, you could actually, there's a brass line in the ground, and you can put your right foot on one side and be in the western hemisphere, and your left foot in the eastern hemisphere, because that's how you separate them, based upon 0. And so these are semicircles that go from pole to pole, from North Pole to South Pole, and 0 is in England. Opposite it would be the 180th meridian, and it has a different name. It's called the International Date Line. We'll look at that in just a minute. So you're going to see, since it's basically a sphere you're talking about, you will divide it by 360 sections, and you'll see that it's also about 111 kilometers. So when you use a latitude, which goes east-west like an x-axis, and longitude, which is the other way, you're going to be able to coordinate or make a coordinate of any place on the Earth. So you're also going to see that the sun is only in one place and the Earth is going around. And so time, normally, we've always for eons depicted time based on the sun. Where's the sun in the sky? And so the Earth is now divided into 24 time zones. So about 15 degrees apart from each other. And as the Earth is turning 15 degrees, the sun changes position in the sky. And so the sun rises in the east and sets in the west. And so it takes 24 hours for the Earth to go around, so there's 24 time zones. So you've got about a 15 degree of longitude. Now, a lot of times that on a map will go right through the middle of a town or something like that. So sometimes one state would all like to be in one time zone to make it easier. So the time line kind of changes so that it goes around a city or it goes around a state, or one state will adopt another or this. When you get to China, for instance, which is thousands of miles wide, every town is in the same time zone in China because it's convenient, I suppose, for the federal government. Okay, and then the last thing, the international date line, is the 180th meridian, and so that means that as soon as it crosses the 180th meridian, that as it's turning, that will be the first city that will experience midnight. Okay, so as it goes around, it becomes midnight, and then 15 degrees more as it turns, it becomes midnight, and so, for instance, China is already in tomorrow. We are in whatever day we're in, and China is 12 hours ahead of us. Okay, so they're going to be in the next day before we are.